function is a function whose rule is f evaluated at x is equal to this bar around x. Okay, so you have these straight bars. The definition of the absolute value function is given by a piecewise function. So that function is going to be negative of that expression when x is less than 0 and positive when x is greater than or equal to 0. Okay, so if we look at this example where our absolute value is 5x minus 7. Okay, so we want to graph the function of the absolute value 5x minus 7. We're going to use our definition to create our function before we even start graphing. Okay, so first thing we want to define, this function f of x is going to be equal to, using the definition, the negative version of 5x minus 7 if x is less than 0. And it's going to be the positive version, 5x minus 7, if x is greater than or equal to 0. Okay, now I have to be careful of what this x represents right here. Okay, it's not just a plain x in my definition, it's actually where that expression is less than 0 and greater than or equal to 0. Okay, so I need to do a little bit of modifying here. So I'm going to solve this inequality to help us. So we want where 5x minus 7 is less than 0 and where 5x minus 7 is greater than or equal to 0, which is essentially solving the same inequality. Okay, so if I solve that little mini inequality, adding 7 to both sides gives us 5x greater than or equal to or less than, it does not matter, 7. And then divide both sides by 5, and so x is greater than or equal to 7/5. Okay, this is our pivot point, essentially, in the absolute value. So this is the place where you're going to see that vertex. You're going to see where the two lines intersect each other. Okay, so my actual piecewise function to graph the absolute value of 5x minus 7 is going to be the function negative, and let's go ahead and distribute while we're here so that we have this all simplified. Let's distribute that negative across. So we'll have negative 5x plus 7 if x is less than 7/5, and then we'll have 5x minus 7 if x is greater than or equal to 7/5.
So every time we have absolute value, we have to solve that x where you do the 7/5.
Yes, because you want to find where its pivot point is. Yes. Okay, so now from this piecewise function, I'm going to do the same process I did for the last two piecewise functions, look at each one individually and plot my points. So let me show this over on the right side. So if we have the negative 5x plus 7, where x is less than 7/5, my starting point is 7/5. And so I'm going to have 7/5, but everything's smaller than it. So let's see, 7/5 is 1 2/5 to kind of give us perspective, right? So maybe I want to plug in something smaller. 0 is always easy to plug in. And how about negative 1? Okay, so when I choose my values, I'm going to substitute in negative 1, 0, and then 7/5. Okay. Of course, I'm not including the point that negative 7 or positive 7/5 is. So I'm going to have an open circle right there for right now. So I'm going to substitute in negative 1. So we have negative 5 times negative 1, which is a positive 5, plus 7 gives us 12. Okay. Then we'll substitute in 0. Negative 5 times 0 is 0, plus 7 is 7. And then 7/5. Okay, so we have negative 5. Let me write this because I know it's a fraction. We get nervous with fractions. Negative 5 times 7/5 plus 7. What happens to the 5? Cancels, and so we have negative 7 plus 7, which gives us 0. Okay, so here are our 3 points. Negative 112 is going to be off the grid, right? Not technically, but off our little grid. So we really just need 2 points to create a line, correct? So I'm going to use these 2 points. 0, 7. So I have 0, 7. And then 7/5, 0. So we said 7/5 is 1 2/5. So we have 1 and just a little bit, 0. And we're going to have an open circle. Squeeze that in there. Open circle. So you can barely see the little light. Okay, second part of the function. Our function is going to be equal to 5x minus 7 when x is greater than or equal to 7/5. So again, my starting point is 7/5. I want values that are bigger than 7/5. So I'm going to start with the 7/5 and choose numbers. Let's do 2 and 3. Okay, so we've actually already plugged in 7/5, right? We did that for the last set of ordered pairs, and we realized that that gave us 0. When we substitute 2, we have negative 5 times 2, which is negative 10, plus 7 is negative 3. Oh, minus 7. Thank you. Caught us. So we have 2 times 5, which is 10, minus 7 is 3. And then when we substitute in 3, 5 times 3 is 15, minus 7 is 8. Okay, plot those points. So 7/5 zeros. Now we're including, right? We have a closed circle because it's greater than or equal to. So I have that circle closed in. And we have the point 2, 3. So 2, 1, 2, 3. And technically 3, 8. Okay, the absolute value is a V-shaped graph. So we're going to squeeze our V in here. V on the left, V on the right.